So as mentioned at the closing of the previous one, this section is all about high availability, where I'm going to talk about Cosmos Database high availability as a starting point. So I'll be covering the Azure SLA for Cosmos DB, how you can configure high availability, and ending a little bit sharing insights on how to migrate from MongoDB on-prem to a Cosmos DB database in Azure. So starting with the Azure SLAs. Most important not just for Cosmos DB, but overall for each and every service in the Azure platform, Microsoft provides SLA service level agreements. So the resource that you should keep in mind there is the azuremicrosoft.com landing page, where you can search for the SLAs. And again, for each and every of those, it's providing you the specific SLA. So what I did is checking back for Cosmos DB, where I have two different SLA levels. So the first option is a 99.99 that's guaranteeing throughput, consistency, availability, and latency for the Cosmos database accounts in a single Azure region whenever I configured any of the 5 consistency levels, or across multiple regions when I'm configuring any of the 4 consistency levels. And I'll talk about the details later on. I can stretch it out to a 99.999 or like a 5.9 SLA whenever I'm stretching out building high availability across multiple Azure regions and enabling writable endpoints. So let me show you again where you can find that information. So if you just search for Azure SLA, again for each and every Azure service, you can find all the SLAs. So what I did here is checking for Azure Cosmos DB and literally copying what it says here. So Azure Cosmos DB, blah, blah, blah. The service offers a 99.99 whenever it's running in a single Azure region with 5 consistency levels or across multiple regions spanning 4 consistency levels. And once I'm configuring multiple regions, it's going to give me the 99.999, and I need to have read and write availability. And again, this is just for Cosmos DB, but you can find that exact information for all the other Azure services. Now, most important is, I'm pretty sure you understand single region, multiple region in Azure, but another important one is consistency levels. So for quite a long time, developers basically had 2 main consistency levels to choose from. A strong one, which means lower availability of the database, but higher latency, or another one that's called eventual. That means higher availability, giving you better performance, but it's harder to program your application since it needs to point and understand multiple region replication. Now, Cosmos DB gives you flexible 5 different consistency levels, and those are region agnostic. By the way, if you want to find out about the different consistency levels, I'm pointing you to the Microsoft documentation that's describing in detail what each and every consistency level means. But more important, how can you configure that? So the first is checking back in the Azure portal, and again, command line options are obviously also valid. So from within your Cosmos database, you can allocate the default consistency. So for now, it's like somewhere in the middle, where session, as you can see here, is the most widely used one, but nothing blocks you from changing it to any of the other settings. You select eventual saving the changes, and that would be pretty much it. The other aspect is the high availability of the database itself, where again, Azure gives you a 99.99 or a 4.9, like in industry terms, in a single Azure region, but it's already high available out of the box, and that's actually pretty cool. But next to that, you can optimize your SLAs and enabling global replication. There's nothing really much more to talk about, but it's more fun to just show you. I'm not going to save these. So first of all, from the high-level overview, it allows me here to enable geo-redundancy. And what it's going to do is replicating to another region, where, by the way, it's keeping compliance regional boundaries into account. And I just enabled this for here. And what it's going to do is replicating from my local environment, Central US, and adding East US too. So it's just randomly picking any of those regions. Besides that, I have a other option where technically I'm literally doing the same, but this time it would allow me to replicate data to other regions beside that high availability one that it's automatically selecting. Now, since I'm already updating the configuration, obviously I can't make any changes here. But for example, if I don't really have to keep compliance regional boundaries into account, I could easily replicate from Central US to, for example, West Europe or to any other Azure region where Cosmos database is available. And then it will replicate. And as you can see here, I can perform the failovers in an automatic way based on some settings or even performing a manual failover. Last thing I want to show you is one of the settings I skipped when creating a new Cosmos database. Because what we have out of the box, and that's why I talked about it before, are these two options down here. Geo-redundancy, as you can see, by default is enabled. But since I wanted to emphasize in this section that you can actually deploy it, but again, keep in mind that the default behavior, Azure CosmosDB, is high available across multiple regions. And that's the 5.9 SLA. The only change you might need to make for the full 5.9s is switching from regional rights from disabled to enabled, and that would be it. Another option we have is scaling out our Cosmos DB. It's not always mapping exactly with high availability, but obviously what it means, if you don't have the full performance backend, it might break your database, or like not really losing data, but mainly shutting down your environment. And that would be pretty sad because you're using or not using the full cloud Azure compute power capabilities. So what you can do is from within your database settings, defining the scaling and playing with any of those numbers. So before talking about migration, let me go back to my already deployed Cosmos DB. Probably faster from here. So from within my data explorer that I used in a previous demo to show you the contents of the database, I can also define specific scaling options. So from here, as you can see, based on your cost estimate, the default is around 1,000 resource units, and nothing would block me from giving me like 5 times better performance, changing it to like 5,000, or if you want 10,000 with a given cost. Obviously, since you're using more compute power. And that's pretty much all it takes to define your performance, which means the better your database runs, the less risk you have for having an outage on your database. Which brings me to the last part in this section where I want to share some words around how to migrate. It's one of the things that I didn't really talk about yet and not really showing in a demo, but the scenario we used so far is I'm running my local MongoDB database, then we switched our application to an Azure Cosmos DB where I'm technically using a new database. But know that you can also migrate. And why am I talking about migrate? Since we're talking about high availability, which means I'm running my database on-prem. At some point in time, I want to migrate it to an Azure Cosmos DB flavor, and I want to optimize my downtime. And that's where migration comes in play. Azure gives you 2 different scenarios using the Azure Database Migration Service and the Azure Database Migration Assistant. And as you can see, it's in preview for now, so it's still pretty new. But what it does, it's a lot more than just migrating MongoDB to Cosmos DB. Azure Database Migration Service, in short, allows you to migrate from about any database source you can think of, Microsoft SQL Server 2005 all the way up to the latest 17, from a MySQL database, Postgres, Oracle database, and obviously MongoDB as well, to an Azure target where the target is not a virtual machine, but the target is an Azure hosted database solution. So for example, the one I'm talking about here, MongoDB on-prem to an Azure Cosmos DB alternative. By the way, this information, again, since it's still in preview for now, is based on a Microsoft Ignite 2018 session that you can watch on YouTube or on the techcommunity.microsoft.com. And if you search for that session-specific number, it's about a 1-hour topic specifically around using Azure Database Migration. Together with another tool, or if you want, extending it, how to manage it. So you start on the left-hand side with your Azure portal, PowerShell, or command line options, integrating with your Azure subscription, connecting to an Azure storage account because obviously it needs a landing pod for your database content that's being migrated, and migrating from a virtual machine into your Azure subscriptions. In between, it's going to build out specific subnets for the data migration service, integrating with other virtual machines if you want, replicating hybrid from on-prem to Azure or the other way around. So it's a really cool service that I think if you really need to migrate larger MongoDB databases to an Azure Cosmos DB, or again, any of the other flavors, then definitely one of the services to look up. And then repeating once your data has been migrated, the only change that you need to make is the connection string in your application, pretty much what we did at the beginning of this course from the MongoDB to the cloud alternative, Azure Cosmos DB.